Please, sir.
Thank you. Good afternoon, all of you present here. Am I audible?
Yes, sir, audible.
Okay. Good afternoon to one and all present here. I'm really happy to see that a lot of responses are there for this FDP, and I wish to congratulate the team of Computer Science and Engineering for organizing such a valuable topic for essential for the present day, because we know that the UGC nowadays insisting on as well as UGC as well as AICTE not to take 100% classes online. I mean yeah, offline, and they are insisting us to adopt some new methodology, maybe like online or hybrid or flipped classrooms, like that, so that you can cover the entire thing. So it is not restricted to only classroom teaching. So my request to all the faculties is, you have attended the FDP, you have learned something, try to adopt that in reality. And you'll come to know what are the difficulties are there, what are the challenges are there in implementing it, so that you can rectify those things on the in the future. So I congratulate all the participants and the team of Computer Science and Engineering. Thank you so much.
Thank you, sir. Thank you so much. So today we have our guest speaker, Dr. P. Kumaran, Assistant Professor, Department of Computer Science and Engineering, National Institute of Technology, Puducherry. He is going to present on the topic Artificial Intelligence of Things, AIoT. So now I request Mr. Syed Ali, Deputy HOD, CFIS, to introduce today's speaker. Syed, sir.
Thank you. Good afternoon, all of you. Kumaran sir, Dr. Kumaran sir, welcome you, sir. Dr. P. Kumaran, currently working as a Assistant Professor in the Department of Computer Science Engineering, National Institute of Technology, Puducherry, Karaikal, since August 2021. Before joining these jobs, he awarded the his worked postdoc doctor fellow in the Department of Computer Science Engineering, National Institute of Technology, Trichy. He awarded PhD degree in the year of 2019 from Anna University, Chennai, with central government fellowships. He received bachelor degree in the field of computer science engineering, the master degree in the field of network engineering from Anna University in the year of 2011 and 2013. He possessed the university first rank and second rank and received the gold medal for both postgraduate and undergraduate in the state levels. He have a more than 9.5 years experience in both teaching and research experience in the various prestigious universities like SRM University, Shastra University, Valtech University. His research area focus on mainly the social network analysis and social internet of things. He have published 28 articles in the various reputed journals and the IEEE, the Springer. He owned 2 patents and currently he serving as an active reviewer of multimedia tools and applications, the Journal of the Supercomputings. He have the lifetime member of the International Association of Engineers and the Institute of Scholars. Welcome you, Kumaran sir.
Thank you, sir. Thank you so much for your introduction. By the way, I should thank the management, by the way, to conduct any such activity. Their support is very important. So, so in this occasion, I should thank them, as well as I should thank the one who invited me for the talk, Usha ma'am, and he has informed me about this FDP some 20 days before. So thank you so much, ma'am. And even at the last minute, I have one more Viva voice at 2:30 to be a chairperson. I requested ma'am yesterday night 11:30 to shift that talk for 3 to 5 instead of 2 to 4. Immediately, ma'am told I will convey this to the dean ma'am, and I'll get back to you. And immediately she get back to with a positive response. So thank you, ma'am. Thank you, dean ma'am, for giving understanding the situations whenever in this field some sudden meeting comes. And also thanks
With
ma'am.
pleasure, sir, with pleasure. Since
Yeah,
we
yeah.
all are in the same domain, we know the difficulty of
Yes,
handling.
ma'am. Yes, ma'am. Certainly, the mail comes from ministry and ACTs. We have to parallelly, handle that.
Pleasure to have
So
you.
thank you so much. Next 2 hours, dear participants, I will give you enlightenment towards the topic which I have chosen today. That should be related to the theme of the Visual Faculty Development Program. Concepts to the real-time applications. I have more than 30 plus real-time applications of applying the AIML, and I hope I will give you the better version of your next step of research towards this field. Okay, so with that I will start the discussions. So first let me share my screen. So I hope my screen is visible.
Yes, sir, visible.
Yes, thank you. So once again, I welcome you all for this last day of the faculty development program. So today I'm going to discuss about, there is a topic is called as artificial intelligence of things. Basically, this is not new to this field. So as the title itself, we have the word of AI and ML. So what I'm going to tell you here is there is a new, or I can say that the real-time possibility of applying AML is still exists. That domain is called as artificial intelligence of things. So when I can say artificial intelligence of things, basically it is the combination of two domain. And this word coined in the year of 2022 when IoT came in 2010. Along with that, we have many variations of IoT like social, SIoT, HIoT, IIoT. So in that, there is we expected that it is some extension of IoT, but it is actually not. There is a new coining of two terminology, that is artificial intelligence and Internet of Things. So when I can say these two independently, these two are well-versed domain. So now I have prepared these discussions in a way that to give a first level or higher level understanding of what basically artificial intelligence, what basically Internet of Things, and when I can connect it, what it basically means. So then if I can connect it, then why we supposed to connect? What is the use for that? So then I will be bringing many real-time applications into the picture. Okay, so before that, we should get back to the history of the word artificial intelligence. In 1950, we have coined this word, and we have a couple of the methods, or I can say algorithms, or models. And after that, there is one such models that are considered as a subset of artificial intelligence, that is called as a machine learning. There also we have introduced many such models, and later on again in 2010 there is evolution from the artificial neural network to the domain is called as a deep learning. There also we found with many models. Basically the word model will be dedicatedly used in this domain. And so when I can see this is what the end, the answer is no. Then even if I look back, the extended version of this history, was still I'm getting some more insight, like a transformation from AI to ML to neural network. Especially in the neural network of ML, we have a deep learning. Then from there we will be getting into currently from 2017 the transformer architecture introduced. From there onwards we will be end up with, currently we are in the generative AI field. So here also we have a multiple models, or whenever you will be doing any work with a traditional approach, say for example text prediction. Say I can say like data science blends data. The next word supposed to be whatever it may be. Say for example, if you want to predict that word, so what was actually the evolution of predicting the next word, or text generation? We initially started with something is called as a probabilistic approach, like a n-gram approach is basically the traditional approach. Later on, we come up with something is called as a neural network based approach, like LSTM, GRU, and RNN. Then whatever the same task, predicting the next word, from a probabilistic approach to a neural network approach, now we will be trying to do the same thing using transformer approach. So what we actually wanted to observe, the perspective of research concern or even the teaching concern, when we are giving clarity to any such topic or a scenario to our students, we should give them a clarity that what was actual roadmap for that, so that they will get a clarity that upon understanding the roadmap and how there will be a transformation of doing the same task from one approach to other approach, they will be thinking to find the alternative approach in their career in future to give a betterment or progress to the field. That is what very, very important when they will be going to industry. In 2017, the transformer architecture introduced by Google, likewise, someone will come into the picture and they will be, they should understand the base properly. They may be a student of ours. They will be come up with a new way of handling the same problem. So this is how we can observe the evolution of the technology. But when I can connect this word with respect to the AI with IoT, probably what it may be, the IoT, before I have the proper bifurcation of discussion of AI followed by discussion of IoT. But when I can connect these two, literally what I'm going to do is I'm going to do a computation. That computation I can basically call the two level of computation, or in two places I can do the computation. Either I may do the computation in edge level, or I may do the computation in the cloud level. But whether I will be doing the computation in the edge level or cloud level, the input should be a data. But what way the computation is something a different field, what way it will be connected? Yes, computation is a different field where we have a broad history of that. I can quickly say in some 2 minutes. Say, for example, we initiated the computing with single machine computing. Then we went to the transformation from single machine computation to a client server architecture. Then we went to something is called as client middleware server architecture. Then we went to something is called as distributed computing. Then we went to something is called as grid computing. Then we went something is called as a cloud computing. Then we went something is called as a fog computing. Then we went to something is called as a edge computing. When you can closely look at this word, edge computing and the single machine computing, both are same. But because of this huge transformation from 1913 to till date, closer to some 70 plus 25, 95 years, the edge computing is also look like a single machine computation, but the capability is different. So that we will see. So now what I wanted to tell you, this is a computation perspective. But what I wanted to connect this computation perspective to here is, in the computation perspective, the data supposed to be given from the environment is called as IoT environment. So we will see what basically IoT environment. When I can say the data is given from the IoT environment to this computation facility, either cloud or edge, but that data is supposed to be processed. When I can say process, then I wanted to bring the AI into the picture. So now what basically the IoT is all about, receiving a data from IoT environment and apply the models of the AI, and you have to decide whether for that data to apply that AI mechanism, you will be recommended, or you will be expected, or the situation demand to do edge computing or cloud computing. So the clarity of edge computing and cloud computing with examples, I will get back to you. So now this is the scenario where if you wanted to connect the AI with IoT, you're supposed to understand the scenario with why I wanted to do that, and what are all the things will be there in the combination of AI and IoT, and how I supposed to execute the task in the scenario, and who are all will be the participants of the situation. So everything we have to see in that aspect. So that is what the whole scenario. What are all the things will be available, and why I have to do that, and how to do that, and who are all will be available in the situations, basically from the expert side, cloud edge side, or security side, or AI side. So in manufacturing of the product side. So it is actually the combination of a big industry, I can say. And there will be a proof for this with the upcoming slides with examples. So now first I will be coming to the combination. If I combine that, basically what I can able to do from the AIoT, the application perspective, what I can able to do, that has been highlighted in the outer circle. Basically I can do applications related to visualization of the data, or I wanted to discover some structure, or I wanted to perform some diagnostics, or I have to do something called a weather forecasting or market forecasting, or I have to do something is called as robot navigation. So the outer circle are the applications basically. When I wanted to do the applications, for these applications are supposed to do operations of either classifications or regression. These two comes under the category of this. Likewise, if these applications we supposed to rely on these techniques, what basically it is, this is what from the artificial intelligence perspective, when we can say, as per the traditional definitions, like AI will perform reasoning, AI will perform knowledge representation, AI will perform planning, learning, many things. But even in the AI, there will be another questions. There will be the other way of understanding the scenario. Why it's supposed to be called as AIoT instead of ML IoT? Because you basically are applying the machine learning models, or if you are applying only the deep learning models, then it will be called as DLIoT. Instead of calling DLIoT or MLIoT, I called AIoT because whether if I can say ML or DL, everything as per this understanding comes under the subset of AI. So that we put the upper side umbrella, AI as the word, then whatever I'm using inside that, everything will be considered as AI. That's why the word AIoT word coined. So now, as per the definition, even though it can able to do any actions, but I know most of the problems are solvable or solved, are going to solve by one of the subtype of AI is called as machine learning algorithm. And even later on, we found that rather than we come up with our own so-called, the technical keyword is called as a feature, we expected machine to get that and do the task. Then we will be end up with something is called as a deep learning. That's how we have the connectivity of the era. But when I can say machine learning, basically this is from the faculty community, we are aware of these first level classifications, supervised, unsupervised, and reinforcement. There itself we have many variations like semi-supervised, and the supervised itself we have some mini short learning mechanism, one shot learning. So we have many variations, but this is the first level umbrella basically we can say. And what is the understanding from the umbrella? The one we will basically do whether classifications or predictions. How it basically do? There will be a sample set of data, and we need to extract the so-called features and make the machine or model to learn. Then we have to give unseen data, and we can test or we can predict whether the model learned properly or not. The other way, it could be something is called as a regression. So classification basically the class label based scenario. Regression basically a continuous value predictions. These are all the basic understanding where we have many methods under each category. And the another important point is, as I have told, the word model. Basically, as per the machine learning perspective, we will be using a dedicated word is called as model. But we have many alternative word. The model is not new for us. From the beginning of before the machine learning algorithm comes, we will be working with a traditional algorithm. There itself, we will be using a keyword like a methods, approach, model. But why it is specifically called here as a model? Because as per this observation, or as per this directions, as per the concern of the machine learning models, a model basically a mathematical expressions. And if you look at further the mathematical expression, it consists of two components. One is something is called as a variable, another one is something is called as a parameter. Say for example, when I am writing something like y equal to alpha x plus beta z, then there are 5 components I could be able to see, like y alpha x plus beta z. So the alphabetics are basically called as the variables, and the alpha and beta basically called as a parameter. So this is how the combination of parameter and variable is called as a mathematical expression. That mathematical expression basically called as a models. So that's how, whether you wanted to use any existing model or you wanted to create your own model, we have to follow this traditional structure, how we are used to follow a traditional structure of learning any programming language. say for example, Java, how basically the methods will be represented, how basically the variables are represented. We try to follow the same structure, the same way here. And what is the interpretation of this? The alpha, beta basically used to represent Greek words, used to represent for parameter. This is the one basically we will change. And the x and z are basically called as a variable which will get the values from the data. And being a researchers, what is our novelty is whether we have to frame our own mathematical model like this, or else we have to give a value for this parameter. That is what we will call as a fine tuning. So how we are basically giving the value for this variable, whether we are randomly giving or whether we have following any approach to give. So that's how we have to look at the research perspective of dealing the machine learning models. And this is the one, the dedicated words we will be preferred to use this. So I have listed all this here. So when supervised learning is the concern, the individual operations of the supervised learning supposed to be represented, supposed to be expressed with a dedicated keyword like this. Instances, basically the test sample, inferences, the result, the process of the result. So likewise, a labeling, training. So everything, there is a dedicated keyword towards the supervised learning, especially classification process approach. So there is something is called as unsupervised. So again, for any scenario, the data is the input. And when I can say data, again, is a generic word. And so this is the time I hope I wanted to tell you one more scenario about the word data in the computer science aspect. So when you can basically see the basic engineering, which will be called as a basic engineering, the basic engineering will be identified, or it will be called with something is called as oil, coil, and soil. So when I can say oil, coil, soil, oil represents mechanical engineering, coil represents electrical engineering, soil represents civil engineering. These three are the basic engineering we used to say, or that is what the engineering community used to say. But rather than calling that the civil engineering, mechanical engineering, or electrical engineering, they used to represent the important raw material that are associated with them. So in that aspect, I can say that the important thing of our computer science is data. Even though we have a computer to do computation, so when I can say do a computation, sir, over which we will do the computations over the data. So for a computer science aspect or computer science perspective, the computer science oil, coil, soil is data. Okay, and when I can say data again, we have a many form of the data. The data may be in the form of number. Data may be in the form of text. So number also will comes under here. And the data may be in the form of image, collections of pixel. Data may be in the form of video. Data may be in the form of audio signal. But again, whatever may be the form of the data, when we are expected the computer to do the task, always it has to be converted to the computer understandable form. Of course, the computer, we know that it will be understood by a binary language. Again, it is not actual understanding. It is for a human being, a representation 0 and 1. But any of the data wanted to be converted to this, first, every data supposed to be converted in the form of numbers. Then either it may be number will be directly taken, or text will be compared to either the ASCII code or Unicode, or image will be represented by the RGB value or any of the format what it has used. Video, again, collections of frame to a number. Audio, then the X and Y coordinate number. So everything will be supposed to be converted to number. From number to, we have to identify binary. That's why in the first year of UG, we used to have the subject of a number system. So why I wanted to tell all these basics, even though it is basic, being a faculty community, we are aware of it. And in the title of the workshops, there will be another important keyword, that is a teaching aspect. When converting AI and ML to a real-time applications, what are all the challenges? And along with that, in teaching aspect, how it's supposed to be looked at. In that directions, I'm connecting all the scenario with the theme of the FDP. So again, when I can say unsupervised, so we have many methods to do. So still the researchers are going on for clustering. We have many methods of clustering if you take a machine learning subject dedicatedly, or anomaly detections, or the anomaly detection in social media or anomaly detection in any domain, we have a huge scope still to even get the funded project proposals. And the association mining and the dimensionality reductions are basically the traditional process are associated with the machine learning. So another important aspect is called as a reinforcement learning. So recently, in the month of January, we attended 1 week workshop on deep reinforcement learning in IISc Bangalore, where there are speakers all over the world, and 2 speakers only from India, where there is a huge, the thing is going on all over the world towards the deep reinforcement learning. Basically, what the whole point is, even we being giving a data and we being giving a feature and we being identifying a model or we being creating a model and make the model to learn and react with a test sample is a one group. As per the supervised or even unsupervised, I don't have any label, simply interpret from the data. So here the whole scenario, the learning pattern itself, something unique and different, as we are already aware of it. So we will be given direct situations to them. So that is basically called as an environment. You have to react with the environment. And every reactions you will be given either the reward or penalty. Based on that learning happened. So we have a huge scope to do a research, especially on this field also. So now this is basically the one of the primary subset of AI, that is machine learning, and machine learning and the models that are available in that. So the another aspect is something is called as IoT. Before I wanted to go for that, I wanted to introduce the one more terminologies to faculty community, and the terminology is called as analytics. So analytics is a new terminology, of course not, but if you look at that, there is something is called as an industry standard. We have to closely look at that, because every evolution or what is the demand of the market will be closely extracted from that industry standard only. Industry 1.0, 2.0, 3.0, 4.0. Currently, we are in industry 5.0. So when I can say industry 1.0, 2.0 towards the manufacturing and thing, when we can look at industry 3.0, then only they are computerized everything. And industry 4.0, they wanted to computerize as well as digitalize. And industry 5.0, that is very important. They wanted to computerize, digitalized, as well as they wanted to be personalized. So with this aspect only, the entire market in the world, the technology that are getting updated, or the new innovations came into the picture, everything closely observe with the need of industry standard. So in that aspect, when I can say analytics, basically we have started with analytics is called as a descriptive analytics. Later on, there is evolution of a diagnostics analytics, is basically a basic data mining techniques. Then there will be evolution of the machine learning, especially it is called as a predictive analytics. But currently, the world is expected to do something is called as a prescriptive analytics. So what it basically, the prescriptive analytics, there is a small difference between these two. When I can say predictive analytics, how basically predictive analytics works. Say, for example, if I have some sample of last 10 days data, with that I have to identify some pattern. I have to identify some pattern or identify some relationship. Based on that, I have to predict the next data. Then it is called as a predictive. But it is other way around, the prescriptive analytics. I have to fix my expected result. So if I wanted to get this result, then what's supposed to be my data? So when I can say this aspect, then the concept of prescriptive analytics came into the picture, even that has been projected here. The same thing, descriptive with visualization, diagnostics, data mining, and predictive machine learning. And currently, the prescriptive analytics also using AI. So the research community are closely looking to give solutions to a different real-time problem under umbrella of prescriptive analytics. So now come to the another terminology that are highlighted in the talk of the topic, that is IoT, artificial intelligence of things. It is not actually the artificial internet of things. When I can say IoT, it is like artificial internet of things. No, artificial intelligence of things. So I wanted to say what basically intelligence here. So that I will tell you at the end of the talk, so that the entire crux we can get it. So coming to that Internet of Things, again, we know that we have a separate syllabus for that, and it basically, the another domain of our computer science field. Everything is yes, answer is yes, but I'm not going to tell all the things. I just wanted to give a crux of what it basically. But before we wanted to go for that, we're supposed to have a skill or knowledge or basic understanding of what basically something is called as a computer network. Before you wanted to connect something else and you wanted to share the data, first you will connect computer. And when you can say connect the computer, then first you have to form something is called as a network. Then we can see, instead of computer, we will connect multiple things and form a network. That's how the transformation of computer networks to Internet of Things. And again, before understanding the computer networks, when I can say transfer the data, basically it is called as data communication. So first we should understand the data communications in the wired and wireless mode, how it basically converted. Then I wanted to do it in the real time by connecting the computer. So understanding of computer networks. Then there is understanding of something is called as Internet of Things. This is how we supposed to have again the proper roadmap or connectivity of understanding the subject Internet of Things. So what here it is, the recommendation is, if we are forming a syllabus to students, or we are teaching the subject to the students, what the proper flow it's supposed to be. In the previous semester, they're supposed to have a skill set of computer networks. Before that, they will be having a skill set of data communications. But even the book itself, we have data communication and networks combined together. But I will not recommend it. Better to have a data communications with detailed understanding, bit level, being a computer science engineer, or then followed by network, followed by Internet of Things, should be a proper flow to understand this. So when I can say Internet of Things, what it basically, or how it will be differ from the traditional or already existing something is called as a computer networks. Rather than connecting a computer, I wanted to connect a different smart objects. When I can say smart, we are expecting that that object should have a capability to do 4 operations. I will come to that 4 operations later. Before that, the primary expectation is it's supposed to have a capability of processing, storing, and communicating. So when I can say if these things are exist for any object, that will be called as a smart object, then I can make use of that. So here even we can see here one of the smart object like umbrella. Whenever if there is a rain and whenever there is a cloudy scenario, automatically it has to turn on the bulb which is attached with the umbrella. So something like that we are expected to do from a normal object to smart object. But when I can say again the normal object to smart object or IoT understanding, I wanted to give a clarity of this IoT architecture. Before that, we should have understanding of this the ISO OSI architecture. So what it basically, first we all over the world, when we can say computer, yes, it is a standalone computer to do a task, fine. When we are expected that there is a demand to share the data from one computer to other computer, that could not be done because this computer is manufactured by one, this computer manufactured by someone else, say for example Dell and HP, they both not having a proper compatibility to share the data. So what we are expected is all over the world, all the manufacturers are went to IEEE and asked them to come up with or give the clarity to an entire world for the common layering architecture. What basically a layering architecture is, I have to transfer data from one place to other place. So everybody should follow, whenever transferring, what are the steps they have followed here, the reverse of the step they are supposed to follow here. If the step is 7, then reverse also supposed to be 7. It is not that here to do this, we will be taking some 10 steps, for here it will be 4 steps. No, it won't be compatible, then it cannot be possible. So that the IEEE design, there is something is called as a open system interconnect. So when I can say interconnect, that word itself we have a many meaning. When I can say international, so 2 different national, likewise 2 different network I wanted to connect. That's why the word inter-network came into the picture. In short terms, we are now currently called as internet. It is actual expansion of internetwork. And why they went to ISO is the one where all over the world they will be having a huge marketing capability. So we are expected, they are the one who properly disseminate this information to the entire world. So that's how the ISO OSI reference model came. The reference model come up with a 7-layer architecture of transferring data from one place to other place from a computer. But what the IoT scenario is something different. I completely wanted to replace, or not, even though the computers are exist, I wanted to bring some smart object into the picture. So when I can say smart object into the picture, then the smart objects are not having the same capability as like a computer. So we wanted to do some alternative regarding to that. So in that angle only, that the ISO reference model come up with some extra layer called as a business layer and service discovery layer. And there will be a separate set of the word is called as a protocol for security, protocol for management. Again, what is the word protocol? Something unique. So the answer is very simple. Even though we have come up with this layering layers like this, and everybody all over the world, they wanted to follow the same, but practically we cannot implement these layers. These layers is like when you can look at this word ISO OSI reference model. It's like a textbook that are available like in a library. They're supposed to learn this, but they wanted to implement it. They could not be able to implement as such. They have to come up with to implement to send a mail. That is a separate procedure. To request for the website, separate procedure. To send the file, separate procedure. And to access the remote computer, separate procedure. So every procedure is supposed to written as a rule, and the set of rule is called as a protocol. And when you can keep all the protocol into the stack, then it is called as a protocol stack or protocol suite. So likewise, for a computer network, we have a protocol suite is like TCP/IP version 4. But it is not only the protocol suite, because even this protocol suite derived by referring this 7-layer architecture only. Likewise, when you can even closely look at that, there are multiple protocol suites are available all over the world to connect from one computer to another computer, like a TCP/IP version 6 protocol suite. And why the word suit came into the picture is, if you can imagine the suitcase, basically, the suitcase is the one which is having the capability to keep the clothes separately, files separately, and that the different compartment we have to keep many things. Likewise, we have a different purpose of protocols are kept it into here. That's why it is called as, the word is called as a suitcase, protocol suite. So now, whether these protocol suites are dedicatedly designed to run on computer, but now you can imagine that the smart object you wanted to connect, whether these protocol suites the protocol supposed to be run on the smart object, the answer is no, because the smart objects are not as capable as like these computers. Because of that, we have a separate set of protocol or rules we have to frame. Like here, if the rule is 5-step, here the rule is supposed to be some 3-step. Here the rule is supposed to be some 8-step. It is not only that we have to reduce the number of steps, even the way how we are going to approach, that also we need to change according to this scenario. That's what the real-time applications can be meet out. So the protocol suite which we have highlighted here, like a COAP, MQTT, XMPP, or 6LoWPAN, and this low power wireless personal area network, these are all the protocols are dedicatedly designed to deal with the IoT scenario. So that we have a separate protocol suite is called as IoT protocol suite or IoT stack. So now what is this? This is what the actual one that are help us to transfer the data from one computer to another computer, or one smart object to another smart objects. So then where it will be run, the protocol suite. So the ISO OSI reference, the TCP/IP version 4 protocol suite, or the IoT protocol suite or stacks are run on operating system. So the operating system is the one where those protocol suites are running. With the help of that only, we are basically bringing the concept of transferring your data into the picture. So as you can see, the real applications of IoT, we have many applications all over the different field, from the basic consumer electronics and automotive transport. So here I have mentioned many applications one by one, like smart home. Recent time, there are many smart home scenarios we have seen in the news also, like the abnormal entry of the human being detected by camera, then immediately alarm, or immediately alert the people, those who are not there in the home, by either in the mode of calling or messaging. So we have seen many such applications. Likewise, we have many applications of IoT, like smart home, smart city, automatic car, retail shop, farming. So these are all some of the applications of IoT. So now the another important component of IoT I wanted to highlight here, because this is very even important. So when I can say all these components are applications, when I can say IoT, what are all the components are there in the IoT, or what is IoT supposed to do a task? Again, the IoT is also like a computation scenario where first it has to get the data. So data is important as an input. Then it has to store the data. Then it has to do an operation is called as a processing. Then it has to communicate the data, whoever wants the data. When I can say the first level, collecting the data, so how the data will be get into the IoT scenario, that is very important point. When I can say data wanted to be there, given to IoT scenario, then it has to be done with, there is a component is called as a sensor. So that is the component basically help us to collect the data. Then we will be storing the data in the IoT scenario or processing. There we will be coming with something is called as edge computing devices or processing units. I can say it need not to be dedicatedly bringing the keyword processing units. Then the processing units itself having the capability of communication. And what if you have wanted to collect the data and wanted to store it, process it, and communicate it, or you wanted to react from the result of the processing, then we will be bringing another component is called as actuators. So these two are the primary components of the IoT scenario, sensors and actuators. But when I can say in the market, there are huge number of sensors are there. Even regular life, we used to have anything in our hand or not, we don't know, but we should used to keep a mobile phone always with our hand, because that is the one device where we can able to keep all our mobile numbers. Because previously we used to write it the mobile number in the diary, but we no need now. And we no need to even memorize that tables of multiplication table of 8. What is the multiplication table of 8? What is the multiplication table of 14? No, we have a calculator. No need to carry a money. We know you have a digital money transfer. So we have one device having all devices. So of course, we're supposed to keep in our hand. In that device itself, we have a multiple sensors to do a multiple tasks. Like being a human being, it is our habit that when we used to speak someone through a phone, it maybe touch the screen or some of the application of the screen, so that when you are keep the phone close to your ears, automatically the screen will disable. That is one feature. And something you cannot able to see in the vertical mode, you wanted to see in the horizontal mode, so automatically it will turn if you have enabled the option. So motion sensor, we have many such cases are there. But you know that who will be the primary source of inspirations of bringing those sensors into the market is our human organs. Our eye will detect the light, our ear will detect the sound, and our nose, our tongue. So everything we basically called as a sensor, and that will be a real inspiration to come up with such kind of practical sensors into the market. And any sensors you wanted to take or you wanted to inspire from the human being, it means that you have to convert it into some law or acceptable fact, so that we have to follow some other physical principles. Then, if you look at that, the first, the temperature sensor is basically called as a thermostat, which is introduced in 1880. Likewise, the infrared sensor, which we are using for our mobile phone or our TV remote, it came in 1940. So any sensors you take, what basically it will do is, it is having a capability to detect, basically a device, it's going to detect any changes in the environment. That the changes may be because of the source of the light, temperature, motion, pressure, air, anything. So any changes in the physical scenario, or we will use called as changes in the physical phenomena that's supposed to be measured by, there is a device is called as a sensor. But any sensor, we are expected that what it basically do, any physical phenomena of what that's highlighted here, that has to be transformed into in the form of electrical signal. But in what form it basically, when the device is detecting, it will be in the form of analog signal, and that has to be converted to a digital electrical signal. That is very important. Why? Because we have a basic drawback of analog signals, need more space to store. Analog signals are prone to noise. To handle that, there will be a compulsory conversions of converting analog to digital. So A to D converter in every sensor. And also any sensor we are looking that we are expected that the sensor supposed to be sensitive to the what for it has been implanted, and it should not be sensitive to the other physical phenomena. Likewise, the value supposed to be a proper value. Say for example, 100 degrees Celsius. It is record like that by the thermostat, but basically it won't be happen in the real time scenario at max 52, 54. That's how we have the record. So likewise, here I have listed a couple of sensor like temperature sensor, smoke sensor, motion sensor, humidity, gas, IR, accelerometer sensor, proximity sensor. What is the idea here is, so these are all the primary source of the data generator or the data collector of IoT scenario. And as I have highlighted here, any form of the analog signal supposed to be converted to the digital form because of the nature of analog signals are not that much capable enough to do any further task. So in the same scenario I told, so when the data is collected, you have stored, processed, and before communicating, you wanted to react from the data. Like whenever if there is a smoke is detected, immediately you wanted to turn on the exhaust fan, or whenever the heat is high in the room, you have to turn on the AC. So such kind of actions you wanted to do automatically. Then you wanted to bring another component is called as actuator. But overall, no, here there are some applications of sprinkler. Every big places or a mall or even many huge people crowd area, we will be having the smoke detection sensor with the automatic sprinkler of the water component. So likewise, this system we have seen many places. So what I wanted to highlight here is the sensors and actuators are the components of IoT. Why I wanted to look at that? So before I wanted to say the answer again, if you wanted to communicate again, you will be supposed to have an option of whether the communication should be a short range communication or long range communications or cellular based communications. We can decide. So what is the conclusion is why we have that much emphasis on those understanding of what is actuators, sensors, and IoT, because the whole picture of AIoT, especially in the real-time applications that are very pinpointedly coined in the title of the faculty development program, real-time applications, the sensors and actuators are the basic source in the real-time devices. And when you are collecting the data, you supposed to know that what type of data you are collected from the sensors. That is very important, because according to the type of the data, you wanted to decide what type of analytics you wanted to do. And based on the type of analytics you wanted to do, you wanted to decide that what type of artificial intelligence techniques you wanted to select, whether you wanted to deal with the text data or image data or a video. Accordingly, if it is a text data, you wanted to come up with a neural network umbrella, you decided to go for RNN or LSTM. Or if it is the image data, you have to decide to go for a convolutional neural network. So such selection mechanism you have to take based on the data, but it is not only that. Another important point, whether the data which you have collected, whether you wanted to apply any of the AI mechanism, where you wanted to apply, whether you wanted to apply on the edge devices or whether you wanted to apply on the cloud devices. When I can say edge devices and cloud devices, there we have a huge scope to do even research, because as you can see, there are the models that are available under the umbrella of AI, most probably capable enough to run on computers. What if you wanted to run those model on edge devices, like a less capable device, which is not as capable like a computer? I will tell you what are all the things, even you are aware of it, like Arduino, a Raspberry Pi, Jetson Nano of NVIDIA, many such microprocessor and microcontrollers are there in the market. So the whole question is, if those devices are capable enough to run those models, say for example, deep learning model, CNN, we are very much aware of it. Will it be run on Raspberry Pi? Like that questions we have to ask. Why you wanted to run on Raspberry Pi? Because when you wanted to expected the real-time application, when you wanted to say real time, when the time is involved in that, then always we are expecting that fast response when something happened. When I can say fast response, immediately it has to be processed, then the computation of edge devices came into the picture. When I can say edge devices, whether the traditional models are take more time to run on edge devices, then you cannot be able to get the flavor of real time. That is very important. So that I told that you are in the place or situations to come up with a new set of models that are capable enough to handle the data on edge devices capability to meet out the or to justify the word is called as a real time. So that is what very important directions I could say. So again, when I can say data, again the data is the high level word, but we wanted to interpret it in our further level. It could not be the same as data. Say for example, the raw data, like you can see here, some numbers and the word keyword rate, it could be considered as a raw data. From this you cannot be able to take any actions, because it has to be come to a transformation of something is called as a data to information, information to knowledge, and knowledge to actionable intelligence. So what it basically, say for example, when I can say data like this, I wanted to interpret this number followed by n and this number followed by e is nothing but some latitude and longitude value. So that latitude is longitude is pointing to a location of this. And also I have to connect that the word red, when I can see over my car dashboard, if I'm sitting inside the car, then I have to connect that this scenario, when I'm sitting in the car is on the road, then the red is the word supposed to be referred to something is called as a red traffic light. So when with these two information, I can come to a conclusion that, oh, there may be a red traffic light in this location. Now I have to connect that what way this location is related to me. Maybe if that is the location, if I am currently driving the car and there will be a red traffic light in front of me, if there is such relationship I have identified, then it is called as a knowledge. Then immediately I have to take action is called as I need to stop the car because of the red light. It is called as actionable intelligence. So this is basically we can see this the pyramid shape in our data mining subject, or to understand about the data. So this aspect only, any data we are collected from a sensor, and we need to do these analytics. So in that aspect, we have again to see the history aspect, how basically the data are stored in the earlier stage, like 1990, after 2010, what kind of data storage updation came into the market, and what way it will differ from the earlier stage. And in the data level, if there is any new set of data came, say, basically the 2010, the word to the big data is coined. It need not to be only structured data, even it's supposed to be semi-structured as well as unstructured, because before that big data came, the nature of the data consuming is some of them are producing the data and others are consuming the data. So what is meant by some of them, like some of the news media, some of the medias, need not to be only news, or some of the newspaper sources are only collecting the data and producing the data, everybody consuming the data. But later on, when the social media came into the picture, and the consumers are used to get the opportunity to produce the data, then the pattern got changed. Somebody produced the data, everybody consumed the data, is transformed to everybody produced the data and everybody consumed the data. So we have transformed to this scenario. Even nowadays, when any such situations happen or anything you wanted to get any clarity of that, rather than going with a Google search, recent time I can say, you can directly take that update from social media, because that is even faster than any of the news media. So in that aspect, I can say that the evolution and the transformation or the pattern change of data from somebody to produce, everybody consume, to everybody produce, everybody consume. The everybody produce, everybody consume is the place where there will be a perfect introduction of the keyword that are coined in 2010 is called as a big data. Then related to the big data, to handle the big data, many market came into the picture and many products are released in the market. Like to store the big data, what would be the a tool we want? To process the data, we have to bring a concept is called as Hadoop. And to store, we have to bring something is called as a piglet. To handle that, we have a query is called as a piglet. So many such to meet out this scenario. But later on, we handled everything. Then we are moved to some other directions to solve the data. So in that, when the storing the data is the concern, currently, the AIoT is the one we are expected to process the data by applying AI into it. And even we read the article 1 week before from Zoho owner. No, the human being supposed to be updated because the AI is writing the code and debugging the code. So when we wanted to be more intelligent than that, then we supposed to update ourselves to retain in the market or sustain in the market. So of course, such updation will be always there. So this is the one comparisons as per the AIoT in the computation aspect, whether we wanted to go with edge computing or cloud computing. So that I will tell you. So before that, when I can say data, when I wanted to store the data, again, we wanted to know what are all the way we can all actually available in the market to store the data. The data may be in the form to store in the relational database, that is a traditional one. So when I can say relational database, when we wanted to teach this computer science to students, whenever there is a discussion of data structures came into the picture, before we wanted to discuss the subject to the students, we supposed to tell them that why you wanted to study the subject. By the way, there are many, when I can say computer and being a computer science engineer, what are all the components are there for the computer? When I can say list the component, there is one of the component is called as a RAM that are very important, because the RAM is the one actually, when you are turn on the computer, you wanted to interact with the computer, it's supposed to be need some interfaces because the computer cannot understand your language. So the interface is called as operating system. But that operating system basically reside in one of the computer memory is called as a secondary memory, that is called as a hard disk. When you wanted to turn on, you wanted to load that operating system from a secondary memory to primary memory. That process is called as a booting. And the primary memory is nothing but a RAM. That is the one that could be accessed by, there is important another component is called as a processor. So we need to fast accessing, then supposed to keep the data in the RAM. And even the RAM space is not as like the space of the secondary memory. So we wanted to make use of the space optimally, so that we have to store the data, process the data optimally. That's how we are bringing the word is called as a data structures. So this is how we need to know connect what for or why we need this. Same way, when there is a situation comes to understand or the subject we need to teach for a database management system. And now we have to bring the word again. There is another memory is called as a storage or as a hard disk. If we wanted to store the data into a hard disk, then we need to do a proper mechanism to store and retrieve or effective usage of the hard disk. So we have something is called as a database management system. So that's how there should be a proper base we need to convey to students or anyone we wanted to say about this. We should convey with this what for we wanted to do that or why we wanted to do that. So in that aspect, I can say there will be to store the data in the form of a column value or key value pair. This is basically a dictionary structure or a graph structure or document structure or a stream structure or time series data. These are basically a different way I can able to store the data. But when I can see, say the AIoT is the concern, what form of data basically I will get? I will get something is called as the time series data, or a single dimension data, or multi-dimension data, or single image or multiple image like a video. Now, if it is a single image, or if we can see something like this, first should I recognize this is the image? If it is an image, I wanted to interpret it what is the image is, then what is the next step? Who will generate the image or from where you can get the image? If you are getting this image from IoT scenario, fine. Then you wanted to identify that the kind of data that are received from the IoT is image. Then you wanted to do any interpretation over the image. You have to bring a AI method into it. Then what AI method you are available with. Likewise, any kind of data, first we have to identify what data you have received. For that, if you wanted to do any analytics on that, what kind of AI model you wanted to bring it. Another important point, if you have preferred the AI algorithm and you have identified what you wanted to do. Another important questions we have to ask that where you wanted to do, whether you wanted to do it in the edge level capable device or a cloud level capable device. So another important aspect I will tell you, recent time, if you globally look at even at the valedictory speech, Sarah has introduced AAC demanded for different mode of educations, and along with that, the same AACT is given opportunity to all over the institutes in the India to start some QAP program or extra UGPG program, and even industries are focusing for automations using AI. But another important domain we have to keep it in our mind. When I can say AI, the AI model or AI devices are wanted to do any task automatically that has to do by relying on data. When I can say data, it either to be received from whether we are feeding the data or it has to observe from the environment is one fact. But another fact we have to see that where it will basically store the data and where it will do all the computations. Whether if all the computations are run or all the data are stored in the places called as cloud, then there will be a equal and important future for cloud architect also. That is, I wanted to tell you, because we are going to the buzzword or the current demand of AI and understanding different AI model and kept on working the project under AI. But another important point is we should also parallelly look at the support given by cloud also. And if there is no support from the cloud, definitely you could not sustain the AI and the AI solutions over the market for a long time. So that there will be an equal important job opportunity, and there will be the cloud supposed to alive when AI wanted to be there in the market for a long time. So what I wanted to tell you from this particular point is, if you are recommending your students, or if you are recommending your PhD scholars or any of your known fellow to do something on this field, parallelly you can recommend them to update their skills to cloud also, because till the AI wanted to be there in the market, the cloud supposed to be there in the market. So now come to this aspect. Here I have listed a couple of AI model that are basically very important to decide. Even though the data you wanted to run a AI model, where you wanted to do that that model supposed to be run, on edge devices or cloud devices. Accordingly, you have to prefer the AI algorithm. If your application demands to run your data on edge devices, the data in the form of something is a mixture of audio and video, and but the edge devices is not having a capability to do that. Then if you wanted to rely on cloud devices, then it will take more time. Then you are in the situations to give a solutions for that. So what is your solutions? You have to design a new AI model that should run those data whatever the way you want it on edge devices. So you have situations to find solutions for that scenario. So that's how we can look at, as I have highlighted at the earlier stage, many applications we are expected to run on edge devices. Still, there will be one of the subtype of machine learning is called as a tiny ML. There are many models are also there in the tiny ML, but still not all the applications are expected to run on that. So another important point when the machine learning aspect, when I can say data, even the current scenario, if you look at all your UGPG students or PhD students wanted to do a research by applying AML model over the data, basically they will be come up with something is called as a data set. The data may be in any form. In the web, no, in the site, they are come up with all the data set. If a classification is the task, they are expected to make their model to do something is called as a training. From the same data, they have to do something is called as a validation. Then they will be coming for testing. Then they will be having something is called as a performance metrics like a precision, recall, F-score, and accuracy. Then they will do some changes and try to increase the accuracy. They wanted to project this as a expected result. But so what I wanted to tell you from this, yes, of course, this is a traditional way. What I wanted to tell you here is whenever I can say the data is not as being curated by yourself. You have taken the data from a source or the data has been identified publicly by the huge research community, then it is called as a benchmark data set. Then what here the point is, who curated the data? We should at least know that information. Whether the person who curated the data is expert one or not, or a situation is given to you. You wanted to do a curation, how you basically do the curation. And when you wanted to do a curations of any data that are belongs to any applications, first you have to ensure that you are the expert of that applications. If so, you can curate it and give the proper justifications of how you have curated. If not, you have to hire the expert to curate the data, because curation of the data is very, very important. And even the student claims that I have collected the data in the Google, and these are all the papers are used that data set to produce the result, and this is the current state of our result. Everything is fine, but along with that, we supposed to ask them who curated the data. Basically, when you can see the data that are related to gene and gene sequences, there will be a one benchmark data set. If you look at that, the background of the data set, who curated the data set, there is the team of 10 from all over the world, including one from IIT Madras, who involved for 3 years for the data curations. So I request as well as recommend the faculty members, whenever if any of your students are coming with you to do a project of AAML, of course you should ask them when the data is they have come up with the data. We need to ask questions like who curated the data, when it has been curated, and how many papers are articulated by using the data set, and what is the current best result of that data set, and who did that, where it has been published. So this the preliminary questions should give a more emphasize insight and meaningful outcome in futures of that data set. So overall, I will be back to the actual keyword of the talk, AIoT. So what it basically, there will be a physical component for data collection, and there will be a computation component like edge or cloud devices, and I have to apply the AI model to that data, either of the scenario. Either of the scenario means either edge or cloud. So here the data demanded to do a computation edge level by using some edge computing devices. Here the data is expected to do some computations in the cloud level. So if edge level or cloud level, we have to decide what basically the AI model is. So I will show, there will be one more diagram connecting all these three. So I will show that will be there at the end. So what is the problem? I will give you one more scenario for this. Say for example, real-time object detections. Many of them are aware of this model is called as YOLO. You only look once. So this model, we have many versions, 5, 8, 10, 11. It goes, it is a best model, state-of-art model also for object detection. But the question is, when we wanted to run this model in edge device like a Raspberry Pi or Arduino, you could not able to do it, because the model takes the model needs a memory storage, as well as the time taken for this model to run will not be capable enough to run on the edge devices. So that there will be a model is called as a YOLO X that has dedicatedly designed to run on edge devices. This is what I wanted to tell you. When if there is no such models are available in the market to run on edge devices, but your application demands to run that particular application on edge devices, then you yourself should identify and come up with your own models. Why I have used again the word model, because it is comes under the ML umbrella. for give solutions for that. This is how the research will come. So the edge devices I'm talking for a long time. Basically, there are edge devices. Basically, that is categorized under the microcontroller, microprocessor, and a single board computer. Accordingly, the comparisons of their applications, comparisons of their processor and operating system capability, comparisons of their CPU clock speed, comparisons of their power consumption, everything is compared here. So now what I wanted to tell you, say for example, there is something is called as a cortex. And here we have a capability to do operations like this. In the huge era, if you can see, there is something is called as Arduino, when you can see a Raspberry Pi. It could be able to do applications related to voice and object detection in image. And even you wanted to deal with a video, that could not be done in any of the devices that are available in the below this. We need to go with something is called as the NVIDIA released something is called as a Jetson Nano, which is cost weight some 12,000 rupees. It is embedded with the GPU, where you can able to do a video analytics in edge devices. So this is how we have the huge evolution of edge devices. So again, the whole point is edge devices is not only the solutions, because if the applications demands to run or react real time, and that time word that is attached with the real, it is very minimal, then always it is expected to run fast. Or you can take some time and run, no problem. Then you can think of cloud computing. So again, what is the situation or application is, say for example, you are in the ATM environment, automatic teller machine, and you are inside the ATM and you are in the process of withdrawing the cash. Immediately somebody get into that and they are try to snatch, try to hit, try to fight with you. And you know that in the current, the ATM is enabled with a multiple camera, 360 camera in multiple angle. And no camera is having something is called as a real-time abnormal activity detection in real time. So what is the whole point is, if there are two persons are there and when there is a occlusion, when there is a fight between them, then it is something is called as abnormal activity. Immediately it has to react. And it has to respond like it has to make a high beep sound to give a alert to people nearby, or it has to immediately automatic call to a police station, or it has to do something to recover from the situations. So in that aspect, the two persons and their behavior supposed to be monitored and reacted immediately. But it is basically called as a real-time applications. So there will be other way around. When you can imagine that there is a drone, the drone is attached with a camera. It try to do a surveillance in the agricultural field, and it is observed that what is the current condition of that agricultural field of this particular area. What is their wind speed, temperature, humidity, and even it could observe that the humidity in the leaf. So what we are asking it to do, it will do, and we can from that the concluded result we can react further. So this is how. Even though it is a real time, when we have a time to react for that rather than reacting immediately, that's how we have to think of whether we need to go for edge or cloud. Okay, so in that aspect, I have listed a couple of examples to even give insight of whether we wanted to incorporate edge or cloud, or whether we wanted to react for the situations later or immediately. So everything can be come to a conclusion. So the first application is something is called as the robot vacuum cleaner. So recent time means 2 years before the MI launched this, and many company also launched this. There will be a robot vacuum cleaner like this. It is attached with the multiple sensors and motors and computation unit, communication unit, and it would supposed to be charged automatically, and there should be a display of their charger level and whatever the operations it has done. So everything it has there. So what it will do, basically it will roam around the entire house get the complete visualization or complete landmarks and landscape of that house, and accordingly when we are giving instructions to that, and it will react. So now the whole point is observing a scenario and keep that scenario, and observing the landscape of the house and keep that house, and react for the scenario, and whenever if there is any obstacle, immediately it has to react for. So what it basically, when we can closely look at all these actions, are something like the data collections at the real time, and processing the data in the edge level, and reacting in the edge environment itself, or the place where it is collected the data itself. So this is one of the applications of combining, that is very, very important. Sensor is the one, it's supposed to give a data, and it has processed in edge level, and it has to use some algorithm to process, whether it capture the image, whether it capture only the signals, then what algorithm it has used, where the algorithm comes from, whether the algorithms comes from AI. And after doing this, we are communicating that results back to, or communicating the results to the customer or the owner. So when you can see, look at the whole scenario, it is involved with something is called as a data, a communication, algorithms are involved to process over the data. So it is the combo pack of AIoT. So this is one of the applications, real-time applications of combining AI with IoT data. So likewise, we have another application is called as a kitchen appliances. So everybody, we are aware of this, the coffee maker. So when we can go to the coffee maker and we are enabling them that how much milk we want, sugar we want, and how much decoctions we want, and we have to get that coffee whatever we want. Rather than that, through app, I can able to give all my recommendations to that coffee maker in terms of communication, and in terms of giving a message from the remote place. Then it has to receive all the informations, and it has to process all the informations, whatever it has been requested in the edge computing device. Then it has to give the results accordingly. Then again, I can say that the data has been communicated and the edge computing happened, and it has to react it. When I can say processing the data, there is a place of AI, because we are aware of what basically AI data is needed for AI, and how the data is received to that AI. So this is another interesting applications of this AI integrated with IoT. AI model integrated with IoT. So every diagram you can visualize this. The AI integrated with IoT. Here also AI integrated with IoT. So likewise, AI integrated with IoT for automatic wiper control. Yes, we have a camera, take the capture of the situations or weather outside. Immediately you have to process those images using AI algorithm and decide that what was the situation outside, whether if it is a rain or snow, accordingly control the wiper speed. So yes, a flavor of AI IoT came, another real-time scenario. So another thing is called as a physical product design improvement. So what is this? Is basically whenever if any product is manufactured, what we will basically do is we will be make that product to use to a customer and get the feedback from the customer about the product. Then we will be upgrade the capability of the product, or we want to do any improvement over the product, that we will do. But that is one way, but it need not to be always rely on the consumer feedback. Instead of that, we will be having a set of sensors that will continuously going to monitor the behavior of the device, when it is supposed to be updated back to the station. With that, we will be doing that improvement of the device. So what basically you can see in the scenario is, rather than expecting the results from the consumer after their usage, even we are continuously monitoring the performance of the product for the better improvement. So this is another important aspect. I can say the integration of AI with IoT. So another thing is called as a smart tightening tool. So what it basically is, we are aware of it when I can say a screw and a screwdriver. That is a basic procedure of doing that. But later on, no, even I have one of the case study, the integration of Bosch with Microsoft. Many automated product they brought into the market. So everything is AI enabled. So when they look at the surface of the wall, and they can see the size of the screw, and they will be decided that so how to screw it, how much rotation it needed, and what is the surface, whether we need to do a fast rotation or slow rotation, or when they initiated with some rotations, according to the reactions from the ball, it has to adjust that the speed, or it will increase the speed, decrease the speed. That's why the word adjust came. Everything we can do automatically. So this is what we can see, the smart tightening tool integrated with the AI with IoT. Likewise, there will be another application is called as escalator. So many places you wanted to use the escalator optimistically rather than running the escalator all the time. Whenever you can detect that there is a human being nearby, in terms of any way you can detect that based on their sound, based on their presence, in any form you can use it. If the sound is used here, then you can turn on the escalator rather than you will be always make them to on. So now where the AI came, when there is a sound, is the data. When you are analyzing the sound, whether if it is a sound or not, if it is a sound of the human being or not, then you are bringing the AI into the picture. Then you are informing to the motor unit to turn on the escalator. Whether it could be directly done this, if the sound analysis AI model is not capable enough to run on edge devices, then you have to do something like capturing in one place, sending that to a cloud environment, process it, and get the result again back from the internet to that the escalator place. So that we only have to decide what kind of applications we are designing in the real time. So another interesting application is called as a school bus fleet operator. So what it basically is, from one place to other place, according to the current situations, they will be identifying what would be the optimized route, so that the entire graph of or map of the locations they supposed to be get updated either through satellite or either through something is called as GPS is there. Like if a couple of people, those who are turned on the GPS in any public places, based on the number of GPS turn on, they will be identifying that what is the crowd size. So such kind of features are there. So now what is this one is where we can see that based on the rush, based on the traffic, they will be giving optimized way to reach it. And also when they can also see that through the app, what is the current availability of seat in the van. When they usually used to go to the school at 8:30, they wanted to go 8:15, and if there is 8:15 buses having the seat or not, so they will be get that update. How basically every seats are enabled with a sensor, and whenever it has been occupied, it will be updated to the app. Through the app, we can able to get it. So when I can see sensor will use to identify the seat is occupied or not, then IoT came into the picture. That not only for IoT of only the sensing component, even after a sensing, it has to update through internet to cloud. From the cloud, the data is pulled by the mobile app and it will be updated to the mobile app. Then through internet, we are seeing that. And when we wanted to give a request to that, we can able to also give a request to the mobile phone, so that the driver came to know that the seat is going to be requested. It has been requested to occupy by someone else. So any kind of such task we can able to do by this. So now the same, the route optimization we can do for the flight also. And even one app is there in the market about knowing any flight, what is the current location of the flight, where it is going. So everything we can able to visualize here. And another interesting thing is parking spot detection. So even multiple malls or many malls, whenever if there is a parking spot you wanted to identify, it has to be help us to identify automatically, provided if the parking spot is allocated for you earlier, you can able to make use of that guidance. So such kind of applications are exist in the many malls in the cities. When Chennai also it is enabled. So another one is drone-based building basic inspections. What it basically is, I have a detailed process of this case study. So whenever we are, constructed the highly elevated buildings like this, and after a couple of time or after a couple of decade, when we wanted to do a maintenance, when I can say maintenance, if there is any defect or if there is any corrosion, something is there, you wanted to identify. Basically, identifying that as like the way how you have made a setup to construct, it is very difficult. Instead of that, we are bringing something is called as a drone, a kind of drone enabled with a camera, and we should have a digital representation of that physical building with us, and there should be a coordination with the drone with this physical building. Like we try to make the drone to fly, and it has to take a it has to take it has to capture that image, and from the image it has to detect that if there is any crack or corrosions are there, then immediately it has to give a proper coordinate of where it is there in the because when I can say this, whether this place is this or this or this, I don't know. So it has to correctly give a proper coordinate in the 3D constructed image also. So whenever if the presence of any crack or anything, then for giving a solutions for that, we have to manually depute the people. But identifying rather than doing manually, we can bringing the drone into the picture. That is what the whole application of this one, the drone based facade inspection. So the drone based facade building inspections. So where the AI came is of course the image analytics in drone, that's supposed to be done, of course, done by the AI models only. Then it has to communicate that locations to the station, again of course through internet only. So this is how we can bringing the AI and IoT into the picture. So this is what is basically your goal, and for that goal, what you supposed to select the AI model, and this is the one which I told earlier, the umbrella of these three. IoT is a data source and bringing the AI algorithm, and decided that whether you wanted to run that algorithm on the data in edge level or cloud level. So combining these three, we are came up with, there is a domain is called as artificial intelligence of things. So now what else? Of course, we will be having a couple of real-time test cases. So I will come to this topic. I have also one more topic to discuss to give a insight of the next possible evolutions is called as a digital twin, or even currently we are having a huge scope to do a research on digital twin. So we have many test cases. So the first set of test cases related to the combination of Bosch with Microsoft. So the Microsoft is the one globally, giving a many AI-based solutions. So bringing all the solutions to the product of Bosch, they are running the market with something is called as automated market automations, full of automations. So this is actually the component of what storage they are using to do automation, what kind of analytics they are doing, and what kind of ML model they are doing, who will be supporting, on what are the products of Microsoft used by Bosch. So this is the market tie-up of their automated product of Bosch. Likewise, this is the applications I told. So this application, so these are all the steps I can say. I don't want to go detail. I'm just giving a clarity. This is how it has to be identified and it has to be mapped, and we have to recover that. So likewise, the another interesting application, as I told you in the one of the example, any manufacturing unit, they wanted, rather than getting the performance of their product by feedback of the customer, they wanted to get the data by implanting many sensors in it. So whether it may be a manufacturing of the car, manufacturing of the toy, the mining scenario, any scenario we can bring in this. So another interesting applications of this combination of AIoT for visually impaired people. So when I can say visually impaired people, there will be a separate domain is called as assistive technology for visually impaired people. So the assistive we can do in different way. We can do assistance in terms of their education, do the assistance for their daily routine life inside the house. We can do assistive devices for walking. So in that aspect, the walking of assistive device for visually impaired, these are all the different way we can able to give assistive mechanism to them. So the one which I have highlighted in the red color to give at least one clarity that if we are prefer to go with substitution and electronic travel aid, so how basically your assistive devices by bringing AIoT, that is AI with IoT. So before that, we should always look at the proper survey and to get a proper clarity about the one which you wanted to do it for them. So like the small, I have bifurcated before 2000, after 2000, what are all the products are there. So after 2000, bringing some ultrasonic sensor or GPS with a camera or some RFID mechanism or some kinetic camera or even some mobile phone camera. They will be having many product in the market. So these are all the images of the product for them for the visual impact. So now by combining here, it will be projected like there will be a device attached with the two sensors, basically a passive infrared sensor, which will help us to identify if there is identification of a presence of object. Then the distance between one object to another object or that object to this device could be identified by using ultrasonic sensor. Then what object it is that could be identified by using camera. Then we are expected this device to react in the scenario without hitting others. So the whole point is, or whole the purpose is, the passive infrared sensor data, ultrasonic sensor data, camera data are processed by the edge computing device that are available here. Then that will help us to decide how it's supposed to move in this path without hitting. So everything is a edge computing associated. But when you wanted to see a passive infrared sensor and ultrasound sensor data are text data, I mean numerical number, but the camera, so it is a video data. So now both the data in the form of number, data in the form of video has to be processed by this. So how you will process? There you have to bring a model into the picture for object detection, object classification. So there you can again see the YOLO-X is the one which will help us to run on the edge devices to detect the object and classify the object. So this is how the real-time project is connected for that application. So come to case study 5, doing the AIoT research in agriculture. So agriculture, we can say it is and I can say the agriculture as well as farming, there will be multiple factors or environments are affecting the crop. Basically something like a rainfall, leaf wetness, temperature, humidity, soil moisture, salinity, climate, dry cycle, many things. So we have a huge scope to do the research because multiple data are possible there. Whether we can do many image processing thing, or even we can do video analytics. For all, the machine learning models are much suitable, like classification, clustering, prediction. So, but the whole point is who will be giving a data to us, even if we wanted to apply this. Again, the IoT, when I can bring the sensor components are the data generator or data giver, like optical sensor, airflow sensor, location sensor, dielectric, soil moisture sensors. So either of the sensors supposed to give the data. Like this, you can see this picture where we can have a sensor for detecting the dew of the leaf, moisture reduction, and nutrition status reduction, leaf wetness reduction, humidity reduction, and sunlight reductions. So we have a multiple sensor involved to completely monitor this. Then we have multiple tanks also, fertilizer tank, water tank, pesticide tank to give actuating reaction. But whether the data collected by the sensor that has to be processed, where it has to be processed, edge level or cloud level. After processing, what it has to give, whether the plant is in need of water, the plant is in need of fertilizer with this amount, the plant is in need of pesticide with this amount, everything to be calculated. So this is a one research map where you can get, so what are all the data basically available in the agricultural domain, and what kind of analysis it is expected, what kind of prediction models we needed, and what kind of results it will give. So this will give overall picture or a connective component to get or to do a research in agriculture. So likewise, another interesting case study, that is healthcare, another interesting real-time applications. Many products are available in the market, bringing IoT with the AI. Basically, the different sensors that I have highlighted, like skin or just electrode sensor, arm cup sensor, piezoelectric sensor, pulse sensor, and each sensor is having their own dedicated purpose for it. And accordingly, we have to decide what kind of AI model we wanted. So this is a one couple of real-time scenario where after COVID, we wanted to have our normal life, then in planned of this thermal camera and thermal sensor in public place. It has to detect the human being and their temperature level. And when it is detected that if they are not wearing mask, that also it identified. And when they are wearing mask, and what is their temperature, and if it is not the normal, then immediately isolate them and check their temperature personally. So this is how we brought many IT solutions to the healthcare domain after COVID. So these are some of the reference image of that. So again, when I can say research aspect, so still we have first categorize what type of data are possible in that domain. Basically, the patient history data, clinical text data, hospital database, health record. So what kind of data basically possible, and what kind of analysis I can able to do it. From that, what kind of a model I can able to bring it, and what kind of results I will get. So this is again the possible research that could able to do in the field of healthcare. So there is no end for that. Even I have 10 more test cases along with the examples, like AIoT in aquaculture, and AIoT in smart manufacturing. So we have huge applications are there. Yes, ma'am. Yes.
Excuse me, sir. Sorry for the disturbance. Sir, shall we finish in another 5 minutes? Or?
Sure, ma'am. Sure.
Okay. Thank you, sir.
Okay. So now the transportation is a domain where still we have a huge scope to do bringing AI into process the IoT data. So what basically IoT data here? The camera that are mounted in front and rear to get the behavior of the person that are in front and back side, and the sensors that are enabled in the fuel tank, tire, and the multiple capacity of the truck to monitor and process the data and give the reactions for that. So this is how we have no huge scope to do all the research in this field. So now the two product which I told, like one is Raspberry Pi, another one is Arduino. So you can look at that. For a Raspberry, this is a Arduino, this is a Raspberry Pi, which is look like a normal mini computer, where we can able to do many real-time applications. Say, for example, this is merely a computer which having a capability to connect a monitors, keyboard, monitor, mouse, and there is operating system to load. So this is the operating system space. This is the SD card where you can able to store the operating system, and how you can basically get the operating system from this traditional site. Basic step to load the operating system. You can get the Raspberry Pi window like this, and you have a facility to interact with the configuration in the command line environment, as well as the graphical user interface. Even you can able to connect that Raspberry Pi through remotely using either the PuTTY or the default Windows is having remote desktop connections. So this is how the Raspberry Pi having some 40 general purpose input output pin, where it will be help us to connect all the sensors like this. The one sensor is real time. I have connected and taken the image of that, and I have recorded the results of that also. So likewise, we can do many computations, whatever I have shown above, that could be done practically here. The same way, the Arduino is another component where we can do many applications, even many school students also doing the applications by using such kind of devices. If we can go multiple expo, that we can witness many things. So here also, the step-by-step procedure I have put it in the PPT to do actions of again. So bringing some small sensor of pulse oximeter and get that the pulse level of the human being and immediately process it. Whenever there is abnormality, immediately we have to make a call to a person whom we have registered, as well as send our current locality to them in the form of message. To get locality, we need the GPS. To send the message, we have a GSM. So such kind of setup we can bring it and we can do it. So now with that, the conclusion is, so this topic is connected with the talk of faculty development program, that is real-time applications of bringing AI and ML. Yes, the IoT is having a huge real-time scope to bring it, and especially the portion which I have connected. If the data is provided by IoT, you wanted to apply AI model, and it is demanded to do it whether cloud or edge. Whether the models are available in the cloud, of course, the current models, whatever available, that are dedicatedly designed to run on the high capable device like a computer. But edge, that is a place where we have a huge scope to do a research. So with that, I will be concluding my session. And thank you all, by the way, attending this session online for last 2 hours. And I should also thank the management as well as the organizers and the coordinator Usha ma'am, who invited me to be there, a part of this. So thank you all, and I leave the forum for audience to have any query or anything to interact. You can do it. I can very well to answer. Thank you all.
Kumaran sir, thank you so much. It was really a wonderful session, and hope all the participants enjoyed your session, sir. So questions will be posted, already posted in Q&A. Shall I read it out, sir?
A webinar chart, it is there in the webinar chart, or
Q&A, question and answer.
Oh, 1 minute. Happy only disease reduction. Yes.
Yeah, only comments they have given.
Yes. Really wonderful. Can you share PPT? Yes,
share the PPT.
And yes, ma'am, I will share. And related to that, the mango leaf disease reduction system, it need not to be mango leaf, any leaf. If you can see the disease reduction system on leaf, first there should be a survey is called as what are all the leaf diseases are possible, and what are all the leaf diseases are major in mango, and if the diseases are common among other leaves like papaya, like guava, like cashew, you just look at it, then there is no best model. And my first PhD scholar identified all possible diseases, and they tried to predict the edge computing model to handle or predict those diseases. So when I can say model, you can simply apply all machine learning, deep learning model. But before that, when you can take applications like this, you try to give a solutions on edge computing AI model. In the one of the slide I have highlighted with the red color, you can try that. And or else you can come up with your own model by proposing limitations of your computation devices. So other than that, I could not find any feedback, ma'am. Yeah, thank you, ma'am. Thank you. I will share, ma'am, after this.
Yes, sir. You
thank you so much,
to me so that I'll share in the
sure.
Okay.
Yes,
so thank you, sir, so much.
Thank you, ma'am. Thank
you. Sir, 2 minutes. Yeah. So thank you all participants. Now I'll request my another coordinator of this FDP, Dr. Sujita ma'am, to present the 5 days faculty development program report.
Yes, thank you, Usha ma'am. Good afternoon, everyone. It gives me a great pleasure to present the report of our 5 days virtual faculty development program on applied AI and ML from concepts to real-world applications in teaching. During this period, 26th May 2025 to 30th May 2025, we have received 837 registrations from various faculty members and research scholars from various universities, colleges throughout the world. The program was started by the coordinator, Dr. D. Usha. With the welcome address was given by Dr. S. Geeta, Dean and Head of the Department, Department of Computer Science and Engineering, Dr. MGR Educational and Research Institute. The inaugural address was presented by Dr. S. Geeta Lakshmi, Vice Chancellor, Dr. MGR Educational and Research Institute, and former Vice Chancellor, Dr. MGR Medical University. The day one was, the topic is a comprehensive overview of AI and ML technologies. The speaker was Mr. Srinivasa Raghavan K, Program Director, Land Administration Department of Government of Tamil Nadu, Scientist G, Deputy Director General and State Informatics Officer. He explains about the artificial intelligence, misconception about AI and ML models. He also explained about the types of machine learning, key algorithms in machine learning. K means clustering. He stated about workflow of machine learning, deep learning, neural networks, and finally he concluded with vector database, languages, and libraries. Day two is, the speaker is Mr. G. Olivannan, explained AI shaping our education. The future is now. He is a vice president in TANCOM. He explained, begins by reflecting on their background in publishing and how even traditional industries like publishing and printing have been significantly transformed by artificial intelligence. The speaker expands on how artificial intelligence is transforming learning, research, and professional practices, and underscores the urgent need to adoption, especially among educators and traditional professionals. On day three, the speaker is Dr. Sheikh Shabana Anjum, Senior Lecturer, Taylor's University, Malaysia. Undergrounds the topic of reinforcement learning and multi-agent system. The speaker explained reinforcement learning problem using Markov decision processes, how to solve oral problem with the help of dynamic programming. She explained about multi-agent oral application in teaching, scenarios, benefits, challenges, and future direction, etc. Also explained how to compute returns from rewards, about the state value functions, Bellman equations, etc. Next day, day 4, topic is supervised and unsupervised learning technique using Python. The speaker is Dr. K. Kanagaraj, Assistant Professor, Department of Information Security, School of Computer Science and Engineering, VIT. He explained with common supervised learning process as well as common supervised learning tasks. He also gave hands-on training for cluster analysis using Google Colab for a sample data. Finally, he concluded with addressing a real-world challenges and solutions. On day 5, the speaker is Dr. P. Kumaran, Assistant Professor, Department of Computer Science and Engineering, NIT Puducherry, Karaikal. He covered artificial intelligence of things, data categories and matching, AI methods, various real-time working models and time applications, as well as AIoT in agriculture analysis, mining and prediction models for healthcare. On day 5, we concluded with a validated session. It was addressed by Dr. N. Yathiraj, Dean ENT, Dr. MGR Educational and Research Institute. All the sessions were highly interactive as well as live demonstrations that truly enrich our learning experience. Thank you all.
Thank you very much, Dr. Sujita ma'am. Now, it's my privilege to present the formal vote of thanks. On behalf of Department of Computer Science and Engineering of Dr. MGR Education Research Institute, I wish to thank our beloved Chancellor, Dr. A.C. Shanmugam, our President, Engineer ACS Arun Kumar, for his constant support in all our journey. My sincere thanks to Dr. M.K. Batmanaban sir, Vice President, Dr. S. Geeta Lakshmi ma'am, Vice Chancellor, Dr. D. Vishwanathan sir, Rector, Dr. C.B. Palanivelu sir, Registrar, Dr. P. Kalidas sir, Senior Additional Registrar, Dr. V. Cyril Raj sir, Additional Registrar, Dr. K.M. Mehta, Advisor, Computing Sciences, Dr. L. Ramesh, Joint Registrar, EPA, Dr. N. Ethraj, Dean, Engineering and Technology, all the deans, HODs, and faculty members of Department of CSE. And I wish to thank specially to all the eminent speakers of this 5 days virtual faculty development program. So first today, Mr. Srinivasa Raghavan sir, Program Director, Lab and Administration Department, Government of Tamil Nadu, and Scientist G Grade and Deputy Director General and State Informatic Officers retired from NIC. Next, Mr. Olivannan, State Vice President, TANCAM. And next, Dr. Sheikh Shabana Anjum, Senior Lecturer, Taylor's University, Malaysia. And then we have Dr. R. Kanakraj, Assistant Professor, Senior Grade 1, Department of Information Security, School of Computer Science and Engineering, Vellore Institute of Technology, Vellore. Then Dr. P. Kumaran, Assistant Professor, Department of CSE, National Institute of Technology, Puducherry. Next, I wish to thank all HODs and additional HODs who introduced the guest speakers every day. So I thank Dr. T. Kripadevi, ma'am, Dr. A. Mageshwari ma'am, Dr. S. Mohandas sir, Dr. M. Anand sir, Mr. Syed Ali sir for introducing the guest speaker throughout the program. My sincere thanks to Mr. Saravanan Ermalai sir, Professor and Deputy Dean University official websites who helped us throughout the program. I would like to thank our system admin team, Mr. Rajesh sir and Mr. Paramasivam sir and team for their continuous support in making the event successful in online platform. My sincere thanks to my co-organizer, Dr. M. Sujita ma'am, and all the faculty friends of our department. Finally, my artful thanks to all the participants who sincerely participated for this 5 days virtual faculty development program event. And without your support, the program will not be successful. Once again, thank you all. So participants, feedback link is posted already. So kindly fill your feedback and it will be available for another 15 minutes. So, and it will not be shared in a WhatsApp group. Kindly fill your feedback in this platform. Okay. Thank you so much.